So this video is around residuals in HLM. I will be showing how to do this in HLM 7, but the general gist applies to any software package. So one thing we haven't talked about are residuals. Residuals are supposed to be normally distributed with a mean of 0 and a standard deviation of 1. So HLM 7 actually puts those out for you, and some of you might have found them um, because they actually end up, if you don't make any changes, in the folder where you also have your MDM file. So I have a model here that just uses the data from the homework and the data that we'd used in class before. And if you want to save and have some control over your residual files, you have to go under Basic Setting, and there is a Level 1 Residual File button. And if that pops up, then it shows you what it's going to do, and it also tells you that you can have the residual file as an SPSS, a SAS, or a STATA. I have no idea what a systat is, and format I assume is a CSV file. And the residual file name is resfile1 in this case. If you don't do anything, you will get that file on the drive wherever that MDM file is. So we'll leave it as is. And then we have here the level 2 residual file, again, file type. It already tells you that it's going to put any level 2 predictor residuals into that file. And so you don't really have to do anything. And we haven't looked at this yet, and we're going to look at this more when we get to different distributions. And but then also in terms of the output file names and things, you can put some things in there. I rarely do. And so if I click OK, as you might have noticed, I really haven't done anything beyond of what I've done before. And so we're going to let this model run and let it terminate, and I actually get the output in the other window, so it's not really relevant right now. And then we can close out of HLM 7. So I've located the res file 1 for the model that I ran, and it's here. And to make this a little smoother, I've opened the file in SPSS, and what you see here is that there's not that many variables in this residual file, but it has the level 2 ID, it has the level 1 residual, it has a couple of things in there that we don't really need to look at, and can actually see that some of these are the same across all. Neighborhood rating is in there, the drug score, the fear score, so you can actually look if there's any relationship between the residuals and the predictors. You can actually investigate this. But the first step would be to just go to analyze the distribution, and just doing this real quickly in SPSS. You can do that in software of your choice. I'm going to ask for a skew and kurtosis and a variance, and then let's see what we're going to get. I have to move this over here. And what you see here, that for the level 1 residuals, we're getting a minimum, a maximum. We're getting a mean of exactly 0. The standard deviation is 0.8, so it's not that far away from 1. And then we have fairly low skew and kurtosis, so I'm pretty happy with those level 1 residuals, and can say that they are they're pretty good in the distribution. However, the other way we can look at this is a QQ plot. And so I can just ask for a QQ plot for that variable to test against the normal distribution. And so just asking SPSS to give that output, you see that this is probably one of the cleanest QQ plots you've seen. It's doing pretty well. There's a little bit of stuff going up there, but that's definitely not a problem. So I want to now look at the level 2 residual files. And if you open that, you will see that there are way more variables in there, and I will not talk about all of these. I will talk about a few of them, and there's some in there that I have never used, and others that might be useful at times. But right now, I want to just give you a general idea of what's in that file. So while looking at the variable view here in SPSS, you can see there is a level 2 ID, so that's just the ID for the unit, and then NJ is the number of units per cluster. So if we're looking here, we have a level 2 ID 111 up here, and we have 8 individuals in there. 112 has 10. You can actually see here these are 42 clusters, so you can scroll up and down. You see that the maximum size is 11 of cluster size, and the smallest seem to be hovering around 4. But it's quite easy now to go in there and then go and ask for descriptive statistics. And SPSS will, in this case, give you the mode, the range, the minimum, the maximum. So I was right with a 4. So that's a way of looking at your clusters as well afterwards and making sure that things work well. Obviously, this is very practical if you have a larger sample. The next thing I want to look at is what's called MDIST. And as you see, there are no labels in there. So if you work with this more frequently, you might want to add labels. This is called the, I don't know how to pronounce this, Mahalanobis distance. And this is a idea of a general level 2 fit of residuals. And that should actually follow a chi-square distribution. So if we wanted to figure out how well this works, we could go and create a QQ plot that uses a chi-square distribution. SPSS lets you do this fairly quickly. So you go under QQ plots the way we've done it before. I've already moved the variable in here. You can go here, and traditionally this is set to normal. This is what will show up if you go in there, and you can then scroll around and you can find a chi-square distribution. And once you click OK, it will give you this. And as you can see, this is not doing that well. I haven't seen them doing that well in general. Then there's a detrended. Remember, the detrended is you want it hovering around 0. So this is going, this has some linear relationship here. I would say that this model is underspecified, that there's something going on that we have not captured. So going back to the level 2 residuals, we then have in here two different residuals. One are the estimated Bayesians, and the other ones are the OLS residuals. And it is good practice to check with all of these how they're doing in terms of distribution and normality. So again, these should be normally distributed. So you can go and create QQ plots against the normal distribution. So we're going to get rid of this variable here, and we're going to put in, and this means expected Bayesian of the intercept, expected Bayesian of the drugs, that's one variable, expected Bayesian of the fear. And then we're the same for the OLS residuals for the intercept, the drugs, and the fear. So we can put all these in there. They should be normally distributed, so you want to change the test distribution to normal and click OK. And you'll have to wait a little bit, and it feeds you back the data. What you see here already is that for the estimated Bayesian, your mean is 0. And they're fairly small here for the OLS distributions. And so when you look at the intercept residual on level 2, you see that this is beautifully normal distributed. When you look at the detrend, it's not bad. It reflects, this. I rarely look at the detrended. Usually this tells you enough. For the drugs, same thing here. It's like a little snake crawling around the normal distribution line. Same for fear. And then we look at the OLS, and we see that the OLS estimates are not producing such nice residuals. There are some patterns in there. The one for drugs looks pretty good, and the one for fear looks pretty good as well, but you can see that this is following a slightly different line. But overall, these are good enough. As I mentioned, the overall fit doesn't seem that great. But this is what you can do with, I don't know what this is, what you can do with your level 2 residuals and to check how they're doing. So if you see major patterns in there, that will indicate that there's a problem. The only last thing I want to point out, at the very end of the data set, you have actually the level 2 variable values for that unit in here. So the mean problem score in the neighborhood here is listed in here as well. So you can actually also run some plots looking at if there maybe is not a linear relationship, but something more going on, where you would be plotting the the mean problem score against the residuals to see if there's anything going on in there. But that's it for the level 2 residual file. So the last thing I want to talk about real briefly is the three-level model residuals. And what you will find is that they look fairly similar to the ones that you've just seen. The level 2 then has, and level 1 have two IDs in there for both of the cluster levels. But you will find similar variables in there, and you would do the same thing. Traditionally, run a QQ plot, and alternatively, you can just also look at mean, the standard deviation, the skew, and the kurtosis. So that's it.